Hi guys! Today we are going to start our discussion about single effect evaporators. So we are not going to discuss kung ano ba tong tinatawag nating single effect evaporator dahil napag-usapan na natin siya sa ating previous video. So kung hindi mo pa napapanood yung ating previous video, I'm advising you na panoorin mo muna yon bago ka mag-proceed dito sa ating lecture for today. Well, since this will be our first discussion about single effect evaporator, magsisimula muna tayo sa pinakamadaling problem. And today we are going to do mass balance in a single effect evaporator. Well, I was supposed to do a mass and enthalpy balance sa evaporator in a single video, but I realized mas madali nating maiintindihan yung enthalpy balance natin if we are already familiar kung ano ba yung mass balance na involved dito sa ating evaporator. So, I decided na gawin muna itong ating lecture about single effect evaporator mass balance and magsosolve tayo ng problem para mas madali nating maintindihan yung susunod nating lecture. So, as I said, dahil ito yung pinakamadaling problem na nakita ko, no? So, there will be no heat balance needed to determine prior to solving kasi marami tayong makikitang mga problems sa single effect evaporator na kailangan muna natin gumawa ng heat balance bago natin ma-identify yung ating mga components dito sa ating evaporator. So dito, hindi muna tayo gagawa ng heat balance dahil i-explain natin yan sa ating next video. And dito, wala rin muna tayong i-consider na boiling point elevation. Okay, so more of that will be discussed sa mga succeeding videos natin about evaporator. So first, bago tayo mag-solve ng problem, identify muna natin yung mga parts ng ating evaporator. Okay, so ito yung typical na diagram ng single effect evaporator. So in here we have our feed. Okay, so we are going to identify this as F. Okay, so our F here is our mass flow rate ng ating dilute feed. So katulad ng napag-usapan natin sa previous video, no, yung ating feed is a dilute solution. So, kaya natin ginagawa itong evaporation process in order to produce a much concentrated na ating solution. Ano? And then here, we have our vapor in which we will have this as V. And dito naman sa ating baba yung ating concentrated product, no, which we also call the thick liquor. And we will be identifying this as L. Okay, so yung F natin dito is our mass flow rate of dilute feed. Ang ating V is yung mass flow rate ng ating vapor. At yung L is yung mass flow rate ng ating liquor. And then, katulad nung napag-usapan natin sa previous lecture natin, no, we have an heat exchange tube right here. And dito dumadalo yung ating steam. Okay, we will be identifying that as S. And then lumalabas ang ating steam dito as a condensate. Okay, so sometimes this is condensed, sometimes not, pero usually condensed ang ating exit stream dito. Okay, which means this is in liquid state. Okay, so katulad din nung binanggit natin sa previous lecture natin, no, yung ating feed which is dilute, meron tayo ditong solute and a solvent, no? And in order to know kung ano ba yung amount ng ating solid dito sa ating feed, we usually express this into mass fraction, no, or solid fraction. So that will be our XF dito. So XF is the solid fraction in feed. So this is dimensionless, okay, because this is a mass fraction. And yung solid naman natin dito sa ating liquor will be XL. And dito sa ating vapor, we have XV, okay, but since this is a vapor, no, dahil ang ginagawa nga natin dito is evaporation, and we are actually separating some part of our solvent as a vapor, then that means we do not have any solute dito sa ating vapor. So this will be equal to 0. So we can just remove that. Okay, so in order to perform our mass balance, we already basically identified yung mga kailangan nating mga variables dito sa ating unit. So, let us now try to do our overall material balance muna, no? So, let me write here, we have our overall material balance. So, ano ba yung ibig sabihin ng ating overall material balance? So, we are going to equate lahat ng pumapasok sa ating unit, which should be equal to all of the component na lumalabas sa ating unit. So, ano ba yung mga pumapasok sa ating unit? We have the mass flow rate of our feed, which is F, plus, pumapasok din yung steam, no? So, you have here our mass flow rate of the steam, which is S, and this will be equal to our components na lumalabas. So, we have our mass flow rate of our liquor here, plus the mass flow rate of our vapor, and plus the mass flow rate of our condensate. For the meantime, let me write this as C. But I would like to explain to you one thing about our unit. So, what is happening here is that we have an heat exchange between the steam and our feed, no? But this is actually an indirect way of heating, which means yung steam natin does not mix with our feed. So, kung ano yung pumapasok nating steam dito, yun din ang lumalabas na material natin dito sa ating condensate. So, if our flow rate of steam here is S, so that means our condensate will also be S. Therefore, our C here actually is also S. Okay? So, that is equal to the mass flow rate of our steam. So, our condensate here is also S. Okay? Because there is no mixing happening between our feed and our steam. So, dahil pareho lang yung amount ng ating steam dito and our condensate, so that means our S will be cancelled out. So, basically, our overall material balance will be F is equal to L plus V. Okay, so madali lang, no? Now, we're going to do solute balance or solid balance. So, in order to have yung amount ng ating solute dito sa ating feed, we will have the mass flow rate of our feed times the mass fraction of our feed. And this will be equal to the mass flow rate of our thick liquor times the mass fraction of our liquor plus the mass flow rate of our vapor times the mass flow rate of our solute sa ating vapor. But as I said earlier, we do not have solid in our vapor, so this will be cancelled out. This will be 0. So that means for our solute balance or solid balance, we have FXF, which is equal to LXL. Okay, so ganyan lang kadali yung ating mass balance dito sa ating single effect evaporator. So now, let us try to solve a problem para ma-apply natin yung natutunan natin for mass balance. So we have here a single effect evaporator in which 20 grams of sucrose per 80 grams of water is to be concentrated to 50% by weight by evaporating the water present on the 1,600 kg per hour feed rate. So our question here is, what is the rate at which the vapor is escaping? Okay, so identify muna natin lahat ng ating given. So we have here our feed. So the mass flow rate of our feed, which is F, is equal to 1,600 kg per hour. Okay? So yan ang ating mass flow rate ng feed. And then, ang component niya is 20 grams of sucrose per 80 grams of water. So we have here 20 grams of sucrose per 80 grams of water. And then we want our liquor down here to have 50% by weight. Okay? So our L here should have 50% by weight of sucrose. Okay? So, yan ang gusto nating makuhang product. But, our required is to get the rate at which our vapor is escaping. So, what is our mass flow rate ng ating vapor? Yan ang ating required na makuha dito sa ating problem. So, we have here our steam coming in and our condensate coming out from this stream. Okay, so let us start by checking kung makukuha ba natin yung sagot natin using our overall material balance, no? So, alam na natin, ang ating overall material balance will just be F is equal to L plus V because our steam does not mix with our feed. So, alam natin yung ating feed which is 1,600 kilogram per hour. But we do not know the value of L and we do not know the value of B. Ito nga yung ating required. So, we cannot use this formula right now. But we can label this as our equation number 1. Okay, so now let us try to use our solute balance, no? Or our component balance. Okay, so let us do component balance here. Okay, so paano natin makukuha yung ating component balance? We already got our formula before, no? We have FXF is equal to LXL plus VXV, but our VXB is equal to 0. So we have FXF is equal to LXL. So we do not know the value of L, and we actually know the value of XL because this is what we want to produce. Itong 50% of sucrose. So what it means is that our XL is equal to 0.5 because this is already a percent weight. So we can convert this into weight fraction or mass fraction, which is equal to 0.5. Okay? So we know our XL, we know our F, but we still don't know kung ano yung value ng XF. Okay, so we do not know the value of our XF, but we are informed that our feed is having 20 grams of sucrose for every 80 grams of water. Okay, so paano natin makukuha yung ating XF, which is a mass fraction, no? Okay, so we have to take note of that. This is a mass fraction or weight fraction. So this is actually not the mass fraction of our sucrose sa ating solution because our solution should be a combination of sucrose and water. So that means the weight of our solution is actually 20 grams plus 80 grams, which is 80 grams of sucrose plus 80 grams of water. So, para makuha natin yung mass fraction ng ating solute dito sa ating feed, we will have, in every 20 grams of sucrose, this will be present on every 20 grams of sucrose plus 80 grams of water. Okay? So, ito na yung mass ng ating solution. No? So, therefore, our XF is actually equal to 20 grams over 100 grams. So, therefore, our XF is equal to 0.2. Okay, so alam na natin yung XF. Alam natin yung F, alam natin yung XF, and alam natin yung XL. So therefore, makukuha na natin yung value ng ating liquor. So we have L is equal to FXF over XL. Okay, so substitute natin yung ating mga value. L is equal to, what is the value of our F? 1,600 kilogram per hour. So we have 1,600 kilogram per hour times our XF. Yung nakuha natin dito, we have 0.2 this is a dimensionless number because this is a weight fraction. Okay, so we have grams divided by grams here, so this will be cancelled out. So we will be dividing that to XL, and our XL is equal to 0.5. Okay, so we have here 0.5, and this is also dimensionless. So therefore, our L is equal to, let us use our calculator. We have 1,600 times 0.2 divided by 0.5. So we have 640 kilogram per hour in our liquor. Okay, pero hindi yan ang ating required. Our required is to find itong value ng V. So we will be using our equation number 1. So we have 1,600 is equal to L plus B. Okay, so we have from equation 1, we have 1,600 is equal to L plus V. Okay, so we have 1,600 kilogram per hour minus, we're going to transpose our L, 640 kilogram per hour, and this will be equal to our V. So our V is equal to 1,600 minus 640, which is equal to 960 kilogram per hour. And that's our final answer dito sa ating problem. Okay? So this is just a normal material balance, no? Or mass balance dito sa ating evaporator. And you will find that this will be very useful sa ating susunod na topic, which is we're going to do a mass and enthalpy balance dito sa ating single effect evaporator. So at least ngayon alam na natin kung ano yung nangyayari na mass balance dito sa ating evaporator, kaya mas mabivisualize natin ng mas madali yung ating enthalpy balance. So with all of that and more, I will see you in our next lecture.